Something is happening beneath one of the most dangerous places on Earth, and new data just came out. Data that changes how we understand what is building up right now under southern Italy, under a city, under more than 500,000 people. I'm talking about Campi Flegrei, the burning fields. And guys, I have to say, when I looked at this new data, I had to read it several times, because what scientists are now seeing beneath that caldera is not what they expected. It's actually worse. So let me break this down for you. Campi Flegrei. You say that name in Italy and people go quiet. This is not a volcano like Vesuvius where you look up and see a mountain and know where the danger is. Campi Flegrei is a caldera, a massive depression. It's 13 kilometers wide, that's 8 miles across, and it formed through two colossal eruptions about 39,000 and 15,000 years ago. Those eruptions were among the largest in Europe's entire history. The ground blew out so violently that it collapsed in on itself. And right now, today, more than 360,000 people live inside its boundaries, with around 1.5 million people in the surrounding region. They are living on the roof of a volcano. They don't even see it. That's what makes this so different from anything else, and it's moving beneath them, right now. The ground has been rising, slowly, silently, relentlessly. There's a word for it, bradyseism. Bradyseism, the slow earthquake. The ground goes up, then it subsides, then it goes up again. For decades, scientists tracked it. They thought they understood it. They didn't, not fully. Because here's what just changed. Stanford University and Italy's INGV, that's the National Institute of Geophysics and Volcanology, they built an artificial intelligence tool, and they pointed it at every seismic recording from Campi Flegrei between 2022 and mid-2025. Old methods had found about 12,000 earthquakes in that period. 12,000. The AI revealed the real number was closer to 54,000. Let that sink in. 3 out of every 4 earthquakes had gone completely undetected. They were there. The ground was shaking. Nobody caught it. And when you now plot all 54,000 of those earthquakes on a map, something emerges that nobody had seen so clearly before. A very thin and well-marked ring fault, consistent with surface features, especially offshore, and also with the area that's being uplifted. A ring fault. Picture that for a second. A circular crack running around the entire edge of the caldera, like the lid of a pressure cooker. And beneath it, pressure is building. Professor Bill Ellsworth, co-director of the Stanford Center for Induced and Triggered Seismicity, said, "These long faults suggest that an earthquake in the magnitude 5 range is not out of the question." Now, I want you to understand what that means for this area, because this is not about some remote mountain. In the deforming area alone, there are about 85,000 inhabitants and 15,000 buildings. And most of those buildings were designed with now obsolete seismic codes or without any seismic provision at all. Without any. And that's just the inner zone. Naples is right next door, the 3rd largest city in Italy. So when scientists say magnitude 5 is possible, that is not abstract. That is buildings, that is streets, that is people. And here's something I found in a study published in Nature's Communications, Earth and Environment that I really want you to hear, because this one stopped me cold. Since 2023, seismicity has progressively clustered along a preferential plane near the center of the caldera, concentrating more than 50% of seismic events and most of the released seismic energy. That clustering is not random noise. Researchers say it is evidence for an internal process that drives the transition from diffuse microseismicity to the development of an extensional volcanotectonic fault in its initial stages. In plain language, the crust isn't just shaking randomly anymore. It's organizing. It's focusing. Energy that used to spread out across the caldera is now concentrating in one zone, one fault. That's what happens before something gives. And the study continues. The nucleation of this fault suggests that caldera rocks are experiencing conditions for critical failure. Critical failure. Those are the scientists' words, not mine. Critical failure of the crust. Now, before we go further, and please stay with me because there's so much more to come, I need to be very clear about something. No agency, not INGV, not USGS, not any official monitoring body, is currently warning of an imminent eruption. There is no immediate eruption alert. There is no magma migration detected toward the surface. I'm going to explain exactly what we do and don't know, because that is what you deserve. But the data right now, this fresh data, is painting a picture that no one can ignore. And further in the video, I'll explain what researchers say the most dangerous scenario actually is. And it's not what most people think. First, let me give you the full picture of where things stand right now. This unrest is not new. Campi Flegrei has not been quiet. The phenomenon of bradyseism remains active and constantly monitored. Between February 23rd and March 1st, 2026, the INGV recorded a peak of approximately 70 earthquakes in the Campi Flegrei area, with magnitudes up to 3.5 concentrated under the Pozzuoli-Agnano area. 70 earthquakes in 1 week. And in October 2025, a swarm of over 40 earthquakes shook the area in a single night, creating serious apprehension among the population. A single night. Then, in 2025, 5 separate earthquakes above magnitude 4 struck the caldera. In May 2025, a sequence of earthquakes with magnitudes up to 4.4 led the authorities to declare a state of emergency in the Campi Flegrei area. State of emergency. Now, let me give you something to put that in perspective. From January 2025 to March 2026, the ground has risen overall by approximately 25 centimeters. That's nearly 10 inches, according to the GNSS station installed at Rione Terra. 10 inches of ground rise in just over a year. At the old port in Pozzuoli, boats now sit stranded in patches of grass. The seafloor has risen so much that areas that were once underwater are now dry land. Ancient Roman columns in that town have fossils of sea mollusks halfway up their length. They were once submerged. That's how much this ground has moved over centuries. And right now, it's accelerating. Late 2025 saw ground uplift rates of 25 millimeters per month between October and December. That slowed to around 10 millimeters per month by early 2026, according to the latest INGV bulletin. But the cumulative rise is enormous. And it's not just the ground moving up, it's getting hotter. The fumarole in the Solfatara crater shows an increasing temperature trend, now averaging approximately 173 degrees Celsius. 173 degrees Celsius, that's 343 degrees Fahrenheit, coming out of the ground. Gas emissions showing isotopically light sulfur. A 2025 study in Nature Geoscience described that as an escalation indicator of caldera unrest. Escalation. So let me give you a favor. Let me explain, and hype this video if you're finding this valuable, because there is so much more to come in this video, and it helps me keep bringing this to you. Now let's talk about what is actually causing all of this, because this is where it gets fascinating, and also deeply unsettling. You hear the word volcano and you picture magma, molten rock pushing up. That is part of the story here, but it's not the whole story. Beneath Campi Flegrei, there is a hydrothermal system. Think of it as a massive underground network of superheated water and gases. Steam, carbon dioxide, sulfur dioxide, pressurized, trapped. When that system heats up, pressure builds. That pressure pushes against the rocks above it. The rocks crack. As pressure builds, the crust responds by cracking along existing faults, producing bursts of small earthquakes that sometimes cluster into swarms. And here's the critical part. Professor Christopher Kilburn at UCL, University College London, has been applying a physics model to this caldera, a model based on how rocks actually break. His study confirmed that Campi Flegrei is moving closer to rupture, and Campi Flegrei's current tensile strength, the maximum stress the rock can handle before breaking, is likely to be about a third of what it was in 1984. A third. The crust there is now 3 times weaker than it was during the last major crisis. Dr. Nicola Alessandro Pino from the Vesuvius Observatory said this: "Parts of the volcano are becoming weaker, meaning it might break even though the stresses pulling it apart are smaller than they were during the last crisis 40 years ago. So you don't even need the same level of stress to get a rupture. The rock has already been weakened by decades of unrest. Each crisis leaves the crust more fractured, more brittle, more ready to give. I've worked around geology enough to know what that progression looks like, and I have to say, when I read that, I felt the weight of it, because this isn't abstract physics. This is the ground that 500,000 people walk on every single day, and now they've found the ring fault, clear, sharp, mapped for the first time. Stanford's Professor Greg Barroza said the Italian colleagues were surprised to see the ring so clearly, and now there's another detail that I found and couldn't let go of. The AI also uncovered something hiding in shallow ground, a source of very shallow hybrid earthquakes likely related to the hydrothermal system. Very shallow, right near the surface. These hybrid earthquakes, part tectonic, part fluid-driven, they are a signature of gas and water forcing their way through cracked rock near the surface, right beneath buildings. Now, let me address something you're probably wondering. Everyone talks about Vesuvius. Vesuvius is the famous one, the one that buried Pompeii. But here's the thing. During the biggest volcanic eruption from Campi Flegrei, about 39,000 years ago, it shot out 72 cubic miles of molten rock. Global temperatures plummeted. Europe and parts of Russia were covered in volcanic ash. 72 cubic miles. That eruption is linked to significant Neanderthal population decline. It may have contributed to a turning point in human prehistory. Scientists think a modern eruption would not reach that scale, but it could still be large enough to wreak havoc on millions of lives and halt air travel across Europe, perhaps even further around the globe. And here is what the director of INGV in Naples, Giovanni Macedonio, said. There really are no countermeasures to protect yourself from the pyroclastic flow of volcanic particles and ash, superheated to some 1,472 degrees Fahrenheit, that would cover terrain at a speed between 30 and 60 miles per hour. Between 30 and 60 miles per hour. You cannot outrun that. Nobody can. Which is why the only protection is getting out early, way before. And that's why the evacuation plan exists. The so-called red zone around Campi Flegrei. Over 500,000 people in that zone. A large red phone at the observatory in Naples connects directly to Civil Protection Headquarters in Rome. The line is tested twice a day. Twice a day. Let that image settle in your mind for a moment. A red phone. Tested every single day, just in case. Now I want to go back to something I mentioned earlier. Because I told you the most dangerous scenario might not be what you're thinking. Here's the thing. Right now, all analyzed seismicity from 2022 to mid-2025 is shallow, at depths above 4 kilometers, 2.5 miles, and does not indicate any migration of magma towards the surface. So no magma signal, no eruption warning. That's the official position, and we have to say that honestly. But the researchers are saying something else is already dangerous, something that doesn't require an eruption at all. Instead of focusing solely on the potential for eruption, planners must now account for the threat of moderate, shallow earthquakes that could damage infrastructure without warning. Moderate, shallow earthquakes. Right beneath those 15,000 buildings built to old codes. Right beneath 85,000 people in the inner deformation zone. A magnitude 4.4 already cracked walls and forced families from their homes in 2025. What does a magnitude 5 do? Or a 5.1? That's the range scientists now say is possible. The buildings there were never designed for that. And the new Nature Communications paper says the fault is developing. It's growing. The seismicity in the first months of 2025 further increases as the number of events and total energy released, confirming the persistence of the same clustering plane identified in 2023 and 2024. Same plane, getting more active, more concentrated, more energy. So what is next? What should we watch? The INGV is now running the AI tool independently, real time. As Professor Barroza said, seismicity could change at any time, and that may be the most important thing about this study. This capability of getting a clear view is now operational. Operational. They can now see what they couldn't see before. 54,000 earthquakes versus 12,000. That's not just more data. That's a completely different understanding of what this caldera is doing. And the authorities are watching. They are watching for retrogressive changes, signs that the fault system is extending. They are watching fumarole temperatures. They are watching gas chemistry. They are watching ground deformation rates. And they have the red phone. There's also something new in a 2026 paper from Geoscience Frontiers. Heavy rains can influence the phenomenon of bradyseism, not only the gases and magmatic fluids in the subsurface. Rain. Water infiltrating the caldera crust, changing pore pressure. Just like what we saw in Sicily with those landslides, the wrong weather hitting the wrong geology. Here, if heavy rainfall infiltrates the fractured, already weakened crust at Campi Flegrei, it can add pore pressure on top of existing hydrothermal pressure. The same physics that destabilizes slopes can destabilize a fault, right? And Campi Flegrei is in a Mediterranean climate. Intense rainfall events are not unusual. So now you have a weakened crust, a mapped ring fault, a developing volcanotectonic fault at the center of the caldera. 54,000 detected earthquakes in 3 years. 5 earthquakes above magnitude 4 in 2025 alone. Ground that has risen 25 centimeters in just over a year. Fumarole temperatures hitting 173 degrees Celsius and still climbing. And buildings that were never engineered to handle what's coming. Can you really say that this is not worth your full attention? I said at the start that this data changes things, and I mean that. Not because an eruption is confirmed, it isn't. INGV is clear about that. But because the picture of this caldera is now sharper than it has ever been. And what that sharper picture shows is a system that is not resting. It is loading, it is crackling, it is changing, slowly, but unmistakably. I've been following this caldera for years. I've been through the data. And I have to say, the combination of what we're now seeing is the most detailed evidence of structural change at Campi Flegrei that has ever been published. That is not me being dramatic. That is what the papers say. And 500,000 people wake up every morning above it, going about their lives, living inside the crater. Some of them know the risk. Some of them have learned to live with it. Some of them have no idea. So I keep watching it. I keep reading the bulletins. I keep digging into the new papers, because someone has to stay on the pulse for you, and I will. So guys, if you found this valuable, give this video an early like and a hype. Share it with someone who should know about this. Leave me a comment. What do you think? Should people still be living inside that caldera? If you want to support the channel, there's a Buy Me a Coffee link in the description. I don't want to promote any company. You know how that works. The videos in the end screen show more about what's happening with ground instability events across Europe right now. Watch those. Stay informed, stay aware, stay safe, guys. Be aware. Bye-bye.